Welcome inside the copper industry. Today, we'll discover how raw copper is transformed into electrical wires and cables.
Copper wire production begins deep inside open-pit copper mines. Copper-rich ore is extracted from layers of mineralized rock. The freshly mined ore is transported to the primary crusher. Large rocks must be reduced before metal extraction can begin. Jaw crushers break giant ore rocks into manageable fragments. This prepares the material for fine grinding.
The ore enters a semi-autogenous grinding mill. Steel balls and ore grind the material into fine particles.
Chemical flotation separates valuable copper minerals from waste rock. Tiny air bubbles carry copper particles to the surface.
The concentrated copper minerals are dewatered into thick filter cakes. This material contains much higher copper content. Oxygen converts the matte into blister copper. Impurities are burned away through oxidation. Molten copper matte contains around 60% copper. It now moves toward converting and purification. The concentrate is smelted at extremely high temperatures. Sulfur and impurities are separated from the copper. Blister copper is cast into heavy anode plates. These plates are prepared for electrolytic refining. Electrolytic refining produces nearly pure copper. Electric current transfers copper atoms to cathode sheets. The finished cathodes reach 99.99% purity. They are now ready for wire manufacturing. Refined copper cathodes are melted once again. This molten metal becomes the foundation of electrical wire. The molten copper is continuously cast into thick bars. This process ensures consistent material quality. Rolling mills reduce the bar into a continuous copper rod. The rod becomes thinner and longer with every pass. The hot rod is rapidly cooled to stabilize its structure. This preserves conductivity and flexibility. Continuous copper rod is wound into transport coils. These coils feed the wire drawing department.
The thick copper rod now begins its transformation into wire. It will pass through multiple drawing dies.
The thick copper rod enters the first drawing stage. Lubricated dies reduce friction and prevent surface damage. Capstan drums pull the wire through each reduction stage. The copper becomes longer as its diameter decreases.
Multiple dies work together in one continuous process. Each stage precisely controls the wire diameter.
Laser sensors continuously monitor the wire dimensions. Even tiny variations are corrected immediately. The conductor continues through progressively smaller dies. Each reduction increases the wire length dramatically. Continuous cooling prevents overheating during high-speed drawing. Lubrication protects both the wire and the drawing dies. Optical inspection systems detect scratches and imperfections. Only flawless conductors continue to production. Optical inspection systems detect scratches and imperfections. Only flawless conductors continue to production. Precise tension prevents stretching or deformation. The conductor remains perfectly round and uniform. The newly drawn wire is collected onto large reels. This allows continuous processing in the next stage. Every reel is weighed and assigned a production code. Traceability is essential for quality assurance. The drawing process has strengthened but hardened the copper. Next, annealing will restore its flexibility and conductivity.
The hardened copper wire now enters the annealing process. Controlled heating will restore its softness and flexibility. The wire is heated to a carefully controlled temperature. This process relieves internal stresses caused by drawing.
Rapid cooling stabilizes the softened copper structure. The conductor regains its excellent flexibility and conductivity.
The annealed conductor is inspected for uniform softness. Precise dimensions are verified before stranding. The softened conductor is rewound for the next process. Several individual wires will soon become one flexible cable.
Several fine conductors are combined to improve flexibility. The bunching machine prepares the strands for twisting.
The conductors are twisted into a stranded configuration. Stranding increases flexibility without sacrificing conductivity. Compacting reduces gaps between the individual strands. This creates a stronger and more uniform conductor. Vision systems inspect the stranded conductor for defects. Only perfectly formed conductors proceed to insulation. The stranded conductor is now complete and ready for insulation. Next, protective layers will transform it into electrical cable.
The stranded copper conductor now enters the insulation department. Protective layers will prevent electrical leakage and short circuits. PVC insulation pellets are fed into the extrusion machine. Heat and pressure transform the pellets into molten plastic. The insulation compound melts into a uniform liquid. Precise temperature control ensures consistent coating quality. The conductor passes through the extrusion die. A uniform insulation layer forms around the copper strands. Cooling solidifies the insulation around the conductor. The protective layer hardens into its final shape. Laser systems measure the insulation thickness in real time. Even microscopic variations are automatically corrected.
The insulation surface is checked for defects and imperfections. A flawless coating is essential for electrical safety. Identification markings are printed directly onto the insulation. These markings provide traceability and technical information.
The insulated conductor is collected for the cabling process. Several insulated cores will soon be combined together.
Individual insulated conductors are assembled into multi-core cable. The next stage combines the separate cores into one unit. The insulated conductors begin twisting into a multi-core cable. Controlled rotation keeps the cable balanced and flexible. The cable cores are now arranged into their final configuration. Small spaces between the conductors must be filled.
Filler materials eliminate empty spaces inside the cable. This creates a strong and perfectly round structure. A binding tape secures the cable components together. The assembly is stabilized before outer sheathing.
The cable core is inspected before receiving its outer jacket. Uniform dimensions are essential for reliable performance. The outer sheath material is prepared in a second extruder. This layer protects the cable from moisture and damage. The sheath compound melts into a uniform protective coating. Precise heating guarantees consistent jacket quality. The multi-core assembly receives its final protective jacket. This outer sheath transforms the assembly into finished cable. The outer jacket is cooled and hardened. This step locks the cable into its final dimensions. The finished cable receives identification and meter markings. Next, every cable will undergo rigorous quality testing. Every finished cable must pass strict quality inspections. Testing ensures safety, durability, and electrical performance. A high-voltage spark test detects invisible insulation defects. Any pinhole or crack is immediately identified. Precision instruments verify the cable's dimensions. Consistent size is essential for proper installation.
Sample cables undergo tensile testing for mechanical strength. The jacket and conductor must withstand heavy loads. The conductor's electrical resistance is carefully measured. Low resistance ensures efficient power transmission.
Insulation resistance testing verifies electrical safety. The cable must prevent current leakage under demanding conditions. Flame retardant testing evaluates fire performance. The jacket must resist flame propagation and self-extinguish. Every meter of cable receives a final visual inspection. Only defect-free products are approved for shipment. All test data is documented and certified. The cable officially meets industry performance standards. The cable has successfully passed every quality requirement. It is now ready for final packaging and shipment. The finished cable is wound onto shipping drums. Precise length measurement ensures accurate customer orders.
The production line automatically cuts the cable to length. Each reel matches its exact specification.
Identification labels provide complete product traceability. Every reel can be tracked back to its production batch. The cable ends are sealed for protection during storage. This prevents contamination and moisture damage. Identification labels provide complete product traceability. Every reel can be tracked back to its production batch. A protective film shields the cable during transportation. The wrapping prevents dirt, moisture, and handling damage. Additional protection reinforces the reel for long-distance shipping. The packaging must withstand heavy handling. A final packaging inspection verifies shipment readiness. Every detail is checked before the product leaves the factory.
The finished reels are transferred to the shipping warehouse. They await dispatch to customers around the world.
Shipping documents complete the manufacturing process. The electrical cable is now ready for global distribution. Each cable reel receives its final shipping identification. The products are now organized according to customer orders. The finished reels move from storage to the loading area. Every shipment is verified before departure.
Specialized equipment loads the heavy cable reels safely. Proper positioning prevents movement during transport.
The reels are secured to prevent shifting during shipment. Every load must withstand long-distance transportation. The shipment is sealed and documented for security. Tracking information accompanies every container. The completed electrical cables begin their journey to customers. From factory to infrastructure, the product is ready to serve. Modern logistics networks deliver cable to industries worldwide. Copper conductors travel thousands of kilometers to reach users.
The finished product arrives where electrical systems are built. These cables become the backbone of modern infrastructure.
Precision-manufactured copper conductors are now carrying power. The journey from raw ore has become usable electricity. From deep underground copper ore to high-performance electrical cable, every strand of copper helps power the modern world.